So I have now started recording. Yeah, okay. Thanks, Rohit. Okay, so yeah, coming back. So in a computer system, we imagine that there are n users who are running their applications. Now, n users may run all the same application, or they may run different applications. Each individual user may even run 2 or 3 applications, right? But so there are several users running several applications on the system, and all of these applications should use the computer hardware, specifically say the processor. Okay, so the processor we are assuming in this course, we will assume we have a uniprocessor system. That means we have only one processor. So all applications will use that processor, and the operating system also. So what is the job of the operating system? It sits in between the application programs and the computer hardware and tries to make it easy for the users to use the computer system, right? So we gave a very high level definition of the operating system, that it is a program that acts as an intermediary between users of a computer system and hardware. Now, of course, this is a very high level definition. We will refine this definition as we go ahead. Okay, so here are the questions which we had started. So the very first question we have answered partially, that what is an OS? So now I hope at least you understand couple of things. First, OS is software, right? So OS is not hardware. I hope the distinction between software and hardware I don't need to explain. So things like processor, RAM, display, these are all hardware. The operating system is a type of software, right? However, it is not an application software. It is something that we call a system software. And I explained this point intuitively yesterday, that application software usually you can think as something that you install, like Microsoft Teams, a browser, a movie player, a video game, right? And a computer game, I mean. So these are application softwares. And system software is usually that software with which a computer modern days come inbuilt. Right, so now if you go and buy a laptop, maybe it comes with preloaded Windows, or you might order a computer with Linux. So these Linux, Windows, these usually come inbuilt. You can install them, of course. You can get a Linux CD, Linux installation CD, and you can install Linux on your system, on your computer. Sure, you can do that. But in general, when you buy a computer, a laptop, say, some operating system comes inbuilt, either Windows or Linux. So those are system software, things which already come, and application software is maybe things which you install. Now, of course, in general, let me clarify something. In general, nowadays computers also come with a lot of application software. So for example, if you buy a laptop with Windows, maybe that Microsoft Office is also provided to you, maybe, right? But that does not make the Microsoft Office a system software. So I hope you are understanding the intuition. Application software are things which we use for our own use, like Microsoft Word, Microsoft Office, a movie player, etc., a browser. But things which we don't use directly, but software which we don't use directly, but of course we need their help. That is like software which so software which actually helps a application program to display something on the monitor, or that software which interprets a key press on a keyboard. So suppose we press a key, what key is that? Some software needs to interpret this, right? Usually we don't install that software. That software comes inbuilt. So that is system software. So operating system is also a system software. In a big sense, you might think it's the combination of all system software. But yeah, we will gradually dive down and make some distinctions clear as to what an operating system is. But basically till now, what is an OS? I think you get the idea that operating system is also software, and it is that software which sits in between your application software and the hardware and enables users to use the computer easily. Okay, any questions at this point? Please write in the chat if yes. Okay, seems not. Fine. Let me proceed. Okay, so next question, as you see, is what are the goals of an OS? Okay, so OS has different goals. We will discuss that. But before that, I want to spend maybe 15 minutes time doing a small activity. So this is an experiment also that I am doing. I hope this activity will make some things clear. But if, I mean, by chance, if it confuses you more, please pardon me. But still, let me try. So yesterday we were having some questions about, yeah, I mean, there can be some confusion as in what the OS, the role or the goal of an OS is, or the role of an OS is, because there are several application programs running. Now, the OS also needs the processor to run. Remember, we said this. The OS also needs the processor to run. So exactly what is going on? So let me just try something for 10-15 minutes. So for that, I need a volunteer or one or two. So let me just say, is there anyone here who is interested in chess? Please write in the chat. Anyone here who is interested in chess? Chess has nothing to do with operating system, but just for this activity. So don't worry if you don't know chess, as in you won't need knowledge of chess to understand this. Okay, nice to see some people interested. Okay, let me pick a couple here. So let's say Ayush and Shiba. Okay. So Ayush, can you unmute yourself?
Hello, sir.
Yeah, okay. Can you hear me?
Yes.
Okay, fine. Okay, so let me present something and maybe I'll have a small discussion with you. So see, let me show you a website. I hope everyone is able to see this website. So Ayush, can you see it?
Yes, sir.
Okay. So it says 5-time FIDE World Chess Champion. Like, you know this person, right?
Yes, sir.
Yeah, who is he?
Vishwanathan Anand.
Exactly. So 5-time FIDE World Chess Champion Anand plays exhibition match with 50 Singapore students. Okay, so you see this picture. There are 50 such students sitting in a room. Let me show you the other picture. See, a huge room with 50 students sitting, 50 children sitting here, 50 Singapore students. And this is Anand. He is playing all of them 50 together. Okay, usually you assume chess 1:1 game, right? But here Anand is playing 50 Singapore students together. How? Let's see. There are a couple of videos. Just few seconds. Let me see. So see, Ayush, can you see the video?
Yes, sir.
Okay. See, this is what is happening. See, this is Anand. He goes to each board, shakes hand of the student. There's a handshake. That's the norm. You do a handshake before you start a game of chess, and then plays a move, and then immediately moves to the next board. Are you seeing this?
Yes, sir.
So see, he goes to a board, shakes the hand of the student, plays a move, and immediately moves to the next board. So this is what Anand is doing. And what is each student seeing? Let's see the next video. So here the camera is focusing on the students. Let's see. See what is happening. Immediately when Anand comes to a board, the student plays a move. Immediately Anand plays his move and moves to the next board. Let me show once again. See what is happening. Anand comes to a board. See, Anand comes to a board. The student plays his move or her move. Immediately Anand plays his or her move. Okay. And then moves to the next board. Is it clear, Ayush?
Yes, sir.
Okay. Now, let me ask you, how is Anand playing 50 students like this?
He has already played or practiced playing many students, and also he might be playing the same opening to. He has the capacity to store the information or remember such things.
Really? I mean, see, really? I mean, okay, let's forget. See, of course, Anand has definitely played many students. Forget it. He is 5-time world champion. He has played many much better chess players than these students. Okay. But again, I also doubt if he remembers 50 chess positions, 50 chess boards like that. Think a bit deeper. So what is the key factor which enables Anand to play 50 students like this together?
I think he's able to analyze a position quickly.
Exactly. Good answer. Anand's brain works much faster than the brain of these students. Maybe the Anand, you can see here, again see this video. How much time does he take? Maybe 1 second, 2 seconds. Okay. Comes to a board, analyzes it. Okay, let me go here, wait. Okay, see, okay, let's see. See, he comes to a board, the student plays the move. Anand takes 2 seconds to analyze the board and plays the move and moves on. So it is sufficient for Anand to invest just 2 seconds in order to analyze a board and play a move. But the student possibly takes a lot of time in thinking what his or her next move should be. Right, because he is having to think about a move by Vishwanathan Anand. So the student takes a lot more time. How much time? Let's say 50 students are there. Let's say on average Anand spends 10 seconds on each, or maybe 5 seconds on each board. So 250 seconds. Right? So after 250 seconds, Anand again comes back to the same person. So now think from the perspective of a student. After 250 seconds, Anand will come back to the same person, same student. Right? So 250 seconds means 4 minutes, 5 minutes. So every 5 minutes, the student is getting a move from Anand. Maybe that is sufficient. The student needs 5 minutes to think about his or her next move. Right, depending on the chess position, the student needs 4 or 5 seconds of the same move. Okay, let me point out a few things more. See, Ayush, I have another question for you. Let's go ahead. See this board. Did you see Anand do something different here in this particular board?
Yes,
Ayush.
I think he touched the opponent's pieces.
Exactly. Let's show again. This particular board. He does something which he does not do with any other board. So before playing his move, he touched the students' chess pieces also. He does not do this for the other boards. Let's see. He just usually he plays his move, but that board he did something different. Ayush, can you say why?
Yes, the opponent made an invalid move, so he did long castling opponent, but he did it in
Exactly.
an invalid manner. So Anand
This
corrected
student,
it.
this move was partly wrong. Anand corrected him and then played his move. Okay. So Anand is doing these kind of things also. So now let us come back to us a bit. So see, here Anand is playing chess with 50 students. And the reason I said is that we discussed Anand's brain works much faster than the brain of a student. And therefore, he can interpret a chessboard in 2 seconds and play a good move. But the students possibly need 5 minutes to interpret the board and interpret Anand's move and then play the board. Exactly the same situation appears in a computer system. The processor is much faster than what we can handle. A modern day processor can do millions or even billions of operations per second. So all of you have done a COA course, right? So you know that the speed of a modern day processor is measured in teraflops, etc., etc. So that means they can do millions and billions of operations, mathematical operations per second. That's why, and that is why, if a particular processor, a modern day processor, is used only by one user, it's kind of wastage of the resources. Just like Anand can play one of these students, but it will be a wastage of Anand's time. Rather, he plays 50 students together. The 50 students feel happy that they are playing with Anand, but for Anand, it's okay. I mean, because his brain works much faster. So similarly, in a computer system, the processor works much faster than what you or I think. You may think, oh, I type pretty fast, but this speed is nothing compared to what a processor can do. And therefore, a modern day processor is able to handle many such users or applications together. Okay. Now, second part of my demonstration, for which let me choose someone else, Shiva. Shiva, can you?
Yes, sir.
Yeah. Okay. So now let's assume that what the task I have for you is, now you have to organize such a meet where 50 students will play Anand. However, there are some issues, like, pandemic situation. Anand is not in India. He is usually in Spain or Germany. So let's say he is in Germany. So in your city, you have 50 students in a room, all of them sitting in front of a chessboard. And what you have is a mobile phone, a smartphone, where an online meeting Anand is going on. Anand is in the remote location, logged in. So the tournament will proceed like this. Let's say that you have this smartphone and there are these 50 students. You will go to one student and give that smartphone. The student takes that smartphone and using the camera shows the board to Anand and the student plays his or her move. Then Anand plays his or her move, which the student himself does, let's say. And then the student hands over the smartphone to you. Is it okay?
Okay.
Is it fine?
Yes, sir.
So now tell me, what would you do? As in, now let me ask you some questions. See, so it's, I hope it's okay how the match is going on.
Yes, sir.
You have the smartphone, you go to a student, give him or her the smartphone. That student shows the board position to Anand, plays his move, Anand plays his move, then the student gives you the smartphone back. Now let me ask, now I have some questions. So the students say that, hey, sometimes 5 minutes is not enough for me. We discussed that maybe Anand takes 5 seconds every time with every student. So 50 students to 50 seconds. That means every 5 minutes he comes to a student. But then some students say that, 5 minutes are not enough for me, depending on the complexity of the board position.
Okay.
Can you do anything different?
So I can send him back in the line so that the rest of the students can play with Anand. Let's say there are 50 students. Yeah.
Good, but let's think. What's the line here? There is no line. The 50 students are just sitting. Can you refine your answer a bit?
So let the game start on student 1. So let's say student 5 requires more than 5 minutes. So after student 4, student 5 says I require more than 5 minutes. So I will skip him and go to student 6. Then go to scoring 50, then to 1, then again come to 5.
Fine. Good, good. So basically you are the organizer, right? So basically you have to go to every student and ask him or her, are you ready?
Yes.
If they say yes, then you hand over the phone. If not, no. See, it's like you have to work too much. Besides, you are disturbing the students by every time going and asking, are you ready? Are you ready? Anything better?
They can give their move on the board, let's say after whatever time they require. So I will move parallelly without asking them, and if they have given the move, I will just start.
I didn't get it. I didn't get it.
So they have their board in front of them, and so whenever they're ready, they can give their move instead of asking them. So if they have given their move, so then yeah, they can be connected to Anand and they can play with him. Means Anand can give his move.
Fine. So do you mean that when a student is ready to give his or her move, suppose they raise their hand, then you go to him or her?
That would be kind of haphazard, chaotic actually. So let's say at the same time 4 or 5 students say that yeah, I'm ready, then that would be chaotic. So I would be moving sequentially, but I would just see their board and yes, they have given their move. So yeah, I will update it on the Anand's position, means on the smartphone.
Okay, so you are right that out of 50 students, maybe 4 or 5 students together may raise their hand saying they are ready. Then you need to decide whom to go to. Right? That's the problem you are saying?
Exactly.
Yeah, agreed. I agree. So suppose if 4 or 5 students are ready together. So see, initially we thought that you will go to every student together. I mean, one by one. But then we understood that some students may require more time. So therefore, instead of that, now we are saying that, okay, when a student is ready, he or she raises his or her hand. And then you go to him or her. But then you pointed out a valid problem that 4 or 5 students may raise their hand together. Then you need some way of deciding to whom to go. Okay?
Okay.
Agreed. I agree. Okay. So now let me choose someone else. So Shiva, thanks. You can mute yourself. Say Dhrumil. Dhrumil, can you unmute yourself?
Yes, sir.
So you heard the conversation I was having with Shiva, right?
Yes, sir.
So would you do anything different?
Instead of, asking everyone and going to their place, we could tell everyone to come to us if they have their move decided.
Mm-hmm.
And
okay.
When they are done, then they can go back to their place. And after they decide their next move, they can join.
Wait. A bit more detail. So you are saying that the rule will be like this. When a student is ready with his or her move, they will come to you or give some signal to you.
Yes.
Whether that student comes to you or you go to the student, that's a different thing. But basically, when someone is ready with a move, they give some signal to you. Maybe they come to you or you go to them, whatever. Then what?
Then after he's done, he'll go to his place and decide the next move. And basically, we'll make sure that they come in a line. So, for example, if we have 1, 2, 3, and if one plays his move and he decides again, then he'll join after the third person, and he'll not just come
right
first every time.
So the problem which Shiba also said, maybe 5 people together, 5 students together tell that we are ready. So you need some policy to decide, right?
Yes.
Okay. Good,
so
good.
Maybe the nearest person at that moment.
Mm-hmm. Okay, good. So some policy. What policy that we can do? That's not the point, but you need some policy. Okay. And see, The other thing is, so suppose you have, so you remember that you have this smartphone where Anand is there, and so basically, when a student is ready with a move, you give the smartphone to him or her, and he interacts with Anand.
Yes, sir.
What if he does not give you back the phone?
I mean,
Yes,
we are
there
the
should be
moderators.
some rule. Yeah.
So I
Maybe
mean,
you are the moderator.
if they have decided the move, then they'll make their move and give it back. No, I
Yeah.
mean, they'll come to me only. They'll signal me only if they are ready. So
Sure, but say some student is a mischievous student. He
okay.
is malfunctioning, like he is breaking the rules. Then you might have to stop him or her.
Yes, yeah, so I mean, we could like give him some time, like 10 to 15 seconds to make his move and
Yes,
then take it back if he
exactly.
doesn't
So
do
let's
anything.
say that the rule would be that when a student gets the smartphone, he should complete his move in 10 seconds.
Yes,
And they
sir.
should return the smartphone to you. Because otherwise Anand is not getting utilized. Like, right. Everyone
Yes,
wants to play. Everyone should get a feel of playing with Anand.
yes, sir.
So the rule is that once someone gets a smartphone, he should complete it in 10 seconds and give it back to you. If not, if someone breaks this rule, you as the moderator, you can actually ask him or her to leave. Like, you are disturbing others, so you leave. You can do that, right?
Yes, sir.
Okay. Good. Fine. So fine. So thanks, Romil. You can mute yourself.
Thank you,
So
sir.
last, okay, Shomnath, since you are also interested in chess, let's give you a chance also. So can you unmute yourself? Shomnath?
Yes, sir.
Yeah, can you hear me? Hello?
Hello. Yes, sir.
Can you hear me?
Yes, sir. Yes, sir.
Okay, and you heard the discussions that I had with Sayush, Shiva, Dhumil?
Yes, sir.
Okay. So now let me ask you, coming back, why am I at all talking about chess, etc., etc.? Has this situation, things that we discussed with Shiva, Dhumil, has it some relationship to our course? So let me ask
Yes.
you. Yeah. Okay. You tell me. What have you thought?
Yes, sir. Because it has relation to this course because say in our computer there are many kinds of there can be many applications running at the same time, so they can be similar to the students and so it may happen that many applications run at the same time or uh,
Okay.
so
Let me ask some more specific questions. So I told about 10 minutes back. Okay, Soumitra, sure, I would not be allowed. Okay, since you have expressed interest, I will soon come to you. But yeah, others, please don't, like, you also don't please say, because somewhere I have to end this and continue with the class. So after finishing with Somnath, Soumitra, I'll come to you for some time. But others, I mean, sorry, I won't be able to discuss individually with you anymore. Okay, so yeah, Somnath, coming on. So see, I said 10 minutes back that the situation is similar to a computer system in a way that just like Anand's brain is much faster than the student's brain, and therefore he can play with 50 students together, a processor is much faster than what we need. So maybe the program that we write or the program that we are using, we need, let's say, 10,000 calculations per second. But the processor, a modern day processor, can do 5 million operations per second. So if I am the only person using the processor won't be utilized because I need only 10,000 calculations per second. That the processor can do 5 million. So that is one parallel. That is why Anand can play with 50 students, and that is why one processor can run so many programs of so many users at the same time. Okay. So I have made that parallel. Anand here is the parallel to the processor.
Yes.
But now let me ask, this course is about operating systems. Who is the parallel for operating system here?
So, I think the moderator means the person who
Exactly.
arranges the.
So if you are organizing this event, you are playing the role of the operating system. And these are some things that the operating system has to do. See here, there are 50 students, each of whom wants to play against Anand. So in a computer system, there can be 50 processors running, 50 applications, each of which wants to use the processor. Now, let me, Somnath, if you do your job well, you being the moderator, every one of those 50 students will feel that they are playing Anand dedicatedly. Do you agree?
Yes, sir.
Exactly the same thing is expected of an operating system in a computer. If the operating system does its job well, then every application should feel that it has the processor by itself.
Yes,
Let
yes,
me
sir.
repeat. Every application in a computer system should feel that that application has its own dedicated processor. Whereas actually that is not the case. The 50 programs are running, we don't have 50 processors, we have just one. But it is the job of the operating system to schedule things in a way such that every program feels that they are getting the whole of the processor. Just like here, if the moderator does his job well, every student should feel that he is playing Anand alone. Anand is dedicated to him. Okay?
Yes, sir.
Fine, Shomna, thanks. You can mute yourself. Shomitra, can you unmute?
Yes, sir.
Okay, but now see, so I hope this part, up till this part is clear.
Yes, sir.
So you are the operating system now, or you are the moderator. But see, Dhrumil, Shiba, they were raising some valid questions. Like see, 5 students may be ready together.
Yes, sir.
Okay, before that, let me point out something else. So see, initially we were telling that the moderator will go to every student and ask, are you ready, are you ready, are you ready?
Yes, sir.
But then we felt that is a bit bad, as in it's too much work for the moderator also. Also, you may disturb the students. Then we said that when a student is ready with his or her move, the student will give you some indication. Agreed?
Yes, sir.
Does that have any parallel with operating system? Maybe we discussed something yesterday.
Sir, in operating system, when we give the input or when we do a job, then we give a signal that now it's time for the processor to work.
Okay, let's speak a bit more technically. Well, see, in general, if you are having a very loose discussion, you say we do this, we do that.
Okay.
But in this kind of a course, you are IIT Kharagpur students, you are doing an operating system course. Let's be more technical. You can't say we do this, we send a signal. Talk in terms of processes. Talk in terms of applications, the operating system, etc. There is no we here.
Sir, so the user when gives.
I hope you understand something. All
yes,
these students who are playing chess, they are analogous to the processors. Sorry, they are analogous to the applications.
Yes, sir.
And Anand is analogy of the processor.
Yes, sir.
Every student wants to play with Anand. Like every processor, every application wants to use the processor.
Yes, sir.
You are in between. You, the moderator, you are playing the role of the operating system.
Okay.
Okay. Is the setup clear? The analogy is clear?
Yes, sir.
So now the question is, yes, actually Ramnivas has given the answer, but that the question I was having is, initially we said that the moderator will go to every student and ask, are you ready, are you ready? But then we found this a bit, it's bad, as in too much work for the moderator also is disturbing to the student. So then we said, when a student is ready, we will give some indication to you. This has an exact analogy in operating system. Can you say what that is? Actually, Ram Nivas has given the answer. This is the concept of interrupt, which we briefly discussed yesterday, but again, so basically every application, when it needs some help from the operating system, gives some signal to the operating system. How, we will discuss that later. The whole course is there. Basically, every application, when it needs something from the operating system, it gives some indication to the operating system, a signal, which is usually called an interrupt. Just like here, every student, when he is ready to with his or her move, gives you, the moderator, some signal. Okay, and then basically, what does the what is your role, Soumitra? What is your role as a moderator?
So to take them to the processor.
Exactly. So basically, most possibly, the application wants some help. Maybe it wants some service. So then it's the role of the operating system to provide that service to that processor. But now, so now think about it. Now let me go into a bit. So I hope till now is clear.
Yes, sir.
But I want to go a bit deeper. Let's see. So here Anand is the processor. So let's say actually talking to Anand or playing a game with Anand is the work which everyone wants to do, right? So as we discussed, 5 students can be ready at a particular point of time.
Yes, sir.
So then you, the moderator, you will have to have some way of scheduling these 5 students.
Yes, sir.
Exactly same is the situation in a computer system. At a certain point of time, 5 applications may be ready. 5 applications are together wanting something from the OS. So the operating system has to have some policy of deciding whom to allocate a resource first. Maybe everyone wants the processor. There are 5 applications which want the processor. See, at a particular point of time, there are 50 applications in the system, but not all of them are ready. By the way, I am talking to Soumitra does not mean others cannot ask questions. If you have questions, feel free to write in the chat. Okay. I hope this analogy is making some sense. Try to understand it. There are 50 students trying to play chess, but not all of them are ready at a particular point of time. They all need different times to think about the next move. Those students who are ready, they give you some indication that we are ready with our next move. But even then, see, Anand cannot be shown the 5 boards together. 5 students are ready, but Anand cannot be shown 5 boards together. Sir. So you will have to decide to whom to give that smartphone to, or to whom to allocate Anand.
Yes, sir. Sir, they have a previous record when they were allotted the previous time.
Yeah.
So I will sort them accordingly.
Perfect. There can be different ways. We will discuss. But the thing to observe is that this is a very valid problem which comes up in the operating system also.
Yes, sir.
Several applications may want the processor at the same time. The operating system has to decide whom to allocate the processor. This is called scheduling. We will discuss this in detail in the course. How an operating system schedules different processors. So basically you have only one resource. Like here we have only one Anand. We don't have 5 copies of Anand. In a computer also we have only one processor. The operating system has to decide whom to allocate that processor at what point of time. Okay. The other thing that I told is, see, so suppose what does allocating Anand mean in this chess game? You have that smartphone where Anand is logged in. You go and give it to a student. That student, and the rule is that that student should play his move, etc., and give the smartphone back to you in 10 seconds.
Yes, sir.
Right? So that's something which frequently happens in operating systems. Operating system allocates the processor to an application and sets some kind of a timer. that maybe that processor, I mean that application should use the processor for 10 seconds only, and then should give it back to the operating system. Okay, this happens. We will discuss these in detail throughout the semester. But again, this is something that operating system frequently does. It allocates the processor to a system, to a particular application, with the understanding that that application should give back the control of the processor to the operating system after 10 seconds. Usually a timer is set, and the timer, I mean, we will discuss the details later, but yeah, I mean, but then I also said that some student may be mischievous. They are doing something illegal, right? So you as the moderator then may have to expel him or her. That you are creating nuisance here. You are disturbing everyone. You leave. I would not allow you to play anymore. Does something similar happen in operating system also? Any idea?
Sir, when the interrupt applications are applications are giving the interrupt to operating system. So if then the application, if the OS check if the timer is more than 10 seconds or not, because it has the previous record. So if it is more than 10 seconds, it will close the application.
Okay, I'm not getting your question.
So means I have to tell the term, or how can it be done a thought? Means I am not getting it.
Okay, fine. Okay, Soumitra, so maybe you mute yourself. Let me ask someone. Maybe Ramnivas? Ramnivas, can you unmute yourself? Okay.
Yes.
Okay, before coming to you, Akshat, you have raised a good question. What can be the problem if we simply order in order of raising hands, etc.? Okay. You are right in one way. There are many different scheduling algorithms possible, and we will discuss those. I am not discussing the specific scheduling algorithm here. I'm just giving an overview of what all kinds of work the operating system has to do. Right? You are right. There can be many ways of scheduling these students. So if 5 students are ready together, how to allocate Anand to them? There are many different ways of doing that. We will discuss that. Yes. Moinak, did you want to say something?
Yeah. So this is to Akshat. This is a great question. And the point is that as you already surmised, that there is a problem in what you told, and we'll actually mathematically see what is the problem and why we need previous history and so on later when we look into scheduling.
Yeah. So today we are not discussing the solutions. We will give 2 or 3 classes for that. We are just understanding the problem, that the operating system can come up with such problems and it has to deal with them, right? Okay, Ram, are you there?
Yes, sir.
Yeah. So I'm saying that some student is creating problems. You have given the smartphone, but he is not returning it back to you in 10 seconds, or he is disturbing others, something like that. So you as the moderator, you have the right to tell him or her, get out. I won't allow you to complete the game because you are disturbing others. I'm asking, do you have any idea? Does the operating system sometimes have to do some such things with applications?
Yes, sir. In case of online applications, like sometimes the server gives the.
Okay, wait. Let's not go too far. Let's talk about what you have done earlier. Let's say write in PDS Lab, etc. When the first year you are doing C programming. Has it ever happened that the operating system has kind of told you something bad? Anything?
Segmentation faults, sir.
Exactly. Good. Excellent. So think about those old days when you used to do PDS Lab, etc. Maybe all of you have had this something called segmentation fault. Again, I'm not going into details, but basically, your program did something illegal. So someone must correct it, right? Or someone must stop you from doing that illegal. Let's say here also in this chess game, if one student suddenly stands up and starts disturbing others, you as the moderator, you have to stop it. You may have to tell that student, get out. I won't allow you to complete. operating system also has this role. If a particular application starts doing something illegal, operating system may have to stop it. In that previous lab, think about it, when you get segmentation fault, usually what happens is your program has tried to access some resource which was not allocated to it. Okay, operating system detects that and stops your program. Understand one thing, that segmentation fault was it printed by your program, Ram?
No, sir. It was printed by
I'm
the
sure that
operating
your
system.
program did not have a printf statement like printf segmentation fault.
No, sir.
So clearly that segmentation fault was not printed by your program. It was printed by some other program which was part of operating system. Basically, your program did something bad, something illegal, so the operating system stopped your program. Right?
Yes, sir.
Okay, so I hope that through this analogy of a chess game between Anand and 50 students, you are able to see some things which the operating system has to take care. But basically, we would say that you are the moderator. Your job is well done if all those 50 students complete their chess games with Anand and feel that Anand was playing with them only. If they have to wait for a long time, so suppose one student is ready, but he had to wait for 10 minutes just to get the next move from Anand, then he would feel bad. So your job as a moderator would be good if you can manage everything such that all the students feel that Anand is playing with him only. Similarly, the job of operating system is to make the applications believe that, a job of an operating system is well done if, like, every application can think that they have the whole processor to use and they are running quickly, etc., etc. Okay, the final thing that I wanted to say, I see that Ishan has already asked that question. See, okay, Ishan, let's not talk about a hacker here. Okay, let's not talk about a hacker here, but I do take one part of your question. Let's see. Okay, again, Nandini has a very good question. Okay, no. So in case of web apps, sometimes we get messages like page took too long to respond. No, those things are not given by the OS, because after all, see, you are running an application, which is the browser, and that browser is talking to some other application in the remote server. So one of those applications gives these messages. That those are not coming from the OS. Okay. Okay, but yeah, okay. Last one thing I have to say. See, in this, again, going back to this chess tournament kind of thing. See, there can be some things which you also need to tell Anand. That maybe you need to tell Anand that, see, only 5 students are ready now. So I will hand it over to 5. So you may also have to need to say something to Anand in order to manage the whole tournament. Agreed? When can you do that? Okay, Ishan, let's unmute yourself. Ishan, may I type? Okay, no, I just wanted to, okay, fine, Ishan, okay, forget it. Okay, since the class is also coming to an end, let me just say, see, for running the whole tournament properly, you also need to tell something to Anand. You may also have to tell some things to Anand. Point to note here is that you can tell something to Anand only when you have the smartphone in your hand. When that smartphone is given to one of the students, then you cannot tell something to Anand. Right? So you also need access to Anand in order to run the whole show. Similarly, the operating system also needs to use the processor at certain points of time. At that point, other application programs cannot run. So the operating system has to manage all this. When it will itself use the processor, when it will allocate the processor to some other application, etc. All these things the operating system has to manage. But understand very carefully that there is only one processor. So only one application or only one program can run at a time. Just like there is only one Anand. Only one person can talk to him at a time. Either it will be one of those students or it will be you. Similarly, in a computer system, there is only one processor. Either one of the application programs will run at a particular point of time, or the operating system itself will run. Now it's up to the operating system to decide when it itself runs on the processor, when it allows other programs to run, etc. Okay. Fine. I hope this analogy was clear. I'm sorry if it has confused you more. I thought that this would help, but I hope at least for some people it made sense. Again, I'll be here for 5 more minutes. If you don't have any questions, you can log off. If you have any questions, you can type here. Ishan says, can the operating system get the control back when it itself is sleeping? Good question. See, it cannot, right? This is the point. It's good that you have asked this question. So Ishan, that's a very good point, which I want everyone to appreciate. Suppose a processor, if a particular application is running on the processor, then the OS cannot get the control back because the OS is not running at that point, right? That's why I said there has to be some mechanism to give control back to OS, right? Think of that chess tournament. You have given the smartphone to a student to talk with Anand. At this point, you cannot talk with Anand. So similarly, if you as the OS, you have allocated the processor to a particular application, then the operating system cannot run at that point. That application is running. But that application cannot just be allowed to go on forever using the resource. So there must be some mechanism so that control comes back to you, the operating system. What is that mechanism? That we will discuss later. But appreciate the problem. When an application is running, OS cannot run. There must be some mechanism to give back the control to OS. That means so that the OS also again gets the processor to run. Because unless the OS has the processor, it cannot also do anything. Remember, no software can run unless it gets the processor. So unless the OS gets the processor, it cannot also do anything. Right, so usually there are some mechanisms which we will discuss. Okay, Srihas has a question. Okay, this question I would prefer to take at some later point of time. As in, that's a very good question, but trying to answer it now will confuse people, I fear. Therefore, wait for a few classes, we will discuss those things. Any other questions? Or Mainak, if you have to say something, please go ahead. Like I don't have anything to say anymore. Some question comes, and Mainak, if you say something.
Yep. So I don't have any specific questions, but there are responses to some, I guess.
Lucky that you don't have any question.
Yeah.
Yeah, I would not like to take questions from you.
Well, sometimes. Yeah. So, but I mean, but more seriously, so these are really, really great questions, guys. The only part that we want to resonate, that I would resonate with SG, is that we'll cover these questions later. By later, yes. I mean that by next 2 weeks. It's not that late. The reason is that currently, as SG told, these are problems that every single OS developer had to face right from 1970s, and people came up with solutions. However, the first step, and this is just it is a very systems course again, so that means that one of the things that we really need to appreciate is that first to raise question. That's the first step of answering it. I know that you have heard it in newspapers and other places, like to perhaps like to answer, like to solve something. The first step of solving something is to first ask the question, acknowledge the problem exists. These are concrete problems that you yourself are raising. We will come each one of these problems, and hopefully it will satisfy your problems. And if not, just let us know. after next 2 weeks. But we do hope, and in fact, this BIOS and OS, and this is a fantastic question. We actually have dedicated 5-10 minute slot to actually show the process in latter point of time. However, if you don't know what OS does, how do you know how OS fits in the bigger picture? So let's wait for that. Okay.
Yeah. So today it's sufficient if you understand the problems. Don't worry about the solutions. As Mainak also said, we will cover them. But understand the issues or the problems that an OS has to handle. Many processors, but only one processor. Many different applications may want the processor at the same time. So the OS has to decide whom to give. Next, if it allocates the processor to a particular application, it needs some way of getting it back. Otherwise, it itself cannot run. And again, should the OS go and ask every process after some time that are you ready, are you ready, are you ready? Maybe not, that is bad. So rather, let the processors decide when they want something from the OS. When they want something from the OS, they will raise a signal or an interrupt. Then only the OS does something. Also another thing, see, suppose that's in the chess tournament again. Suppose that smartphone is given to student X. At this point, student Y raises his hand that I am ready. At this point, you cannot do anything because you don't have that smartphone. That smartphone is with student X. So you will also have to wait for a time when student X returns that smartphone to you, and only then you can give it to student Y. Right? So if the processor is allocated to a particular application X, at that point X is running. Operating system is not running. So now even if Y is ready, operating system cannot do anything. At some point, hopefully X will relinquish that processor. Operating system will now get the processor, and then operating system may decide that to give it to a Y. Allocate the processor to Y. Okay. So these things have to be kept in mind. These will be discussed in detail, but just understand that these are the things which an OS has to deal with. And do not think that the operating system is always running in the computer. That's a very wrong concept. When an application program is running, the OS cannot run because there is only one processor. Right? When the smartphone is given to a student, you cannot talk to Anand. So when the processor is given to a particular application, the operating system cannot run. So do not think that the operating system is always running in the background. So operating system runs only when the processor is allocated to the operating system. The operating system is not running when the processor is allocated to some other application program. So how does it happen? Say, like your program is running now. Suddenly you want to print something. Your program has a printf statement. This is exactly the point when your program should raise a signal that I need some help from the OS. Because your program cannot display things on the screen on its own. It needs help from the OS. So suppose your program wants to printf hello world. It raises a signal to the OS that I need some service. I need some display. Then somewhere the OS will run. And then it will help you to have that display. Again, how, that we will discuss, but understand that this kind of, switching has to happen. Right? So at some point your program is running on the processor. Your program wants some service from the OS. So it raises a hand or a interrupt. Then the operating system will run on the processor. And so this change, like your program was running at some point, after some point the operating system starts to run. This is called a process switching or a context switching. We will discuss these in a lot of detail. Right, so the perfect analogy is that, some kind of analogy is that smartphone in that chess tournament. When the smartphone is given to a student, he is talking to Anand. You cannot do anything. You cannot talk to Anand. Only after getting back that smartphone, then you can talk to Anand, or you can decide to allocate Anand to some other student, etc. Right. So unless the operating system also has the processor, it also cannot run. So do not think that operating system is always running in the background. Okay. Okay, I hope that analogy kind of helped, that chess tournament thing, but sure, there can be lots of questions, so feel free to ask those questions tomorrow. But as I said, that as we go ahead in the next 2 or 3 weeks, many of these questions would be answered. Okay, let's end this class then. Fine. Thanks everyone.